Hello everyone. Let's move to the next topic, that is Bitwise XOR. So how this works, this is represented by this caret or cap, whatever you call it. So how to solve Bitwise XOR. Let's suppose if I write 12 XOR 9, for example. So to solve this, we need binary of 12 as well as the binary of 9. We already have this series. You already know this series from previous videos. So what will be the binary of 12? Check on what numbers we should add to get a 12. 8 plus 4. 8 plus 4 will give us a 12. So put 1 below them and 0 below all the numbers that are not included. So 1100 is the binary of 12, correct? So 1100. What will the binary of 9? By adding 8 and 1, we will get 9. So put a 0 below this and below this. Put a 1 below this. 1001. 1001 is the binary of 9. Okay. Okay. So we have to calculate XOR between them. To do that, we need truth table. Truth table. So what is a truth table? We already know this is used to calculate the operations between logic gates, different logic gates. So let's solve this. 0 XOR 0. 0 XOR 0 will give us, let me write these first. If you want to remember this, it is very simple. Just a second, let me write this one. So if you want to make a truth table, it is very simple. This is how you make it. 0, 1, 10, 11 in ascending order. 0, 1, 10, 11. This way you will remember how to write this. Okay. In XOR, whenever you have similar inputs or all the inputs are same, the output will be 0. Okay. This XOR logic gate will not pass charge forward if all the values are same. So if there is no input or there are all the inputs are low voltage, the output will be a low voltage. So if there are opposite values, okay, there are opposite values or not all of them, all the inputs are same, the output will be 1. So it will flow the charge forward. If the all the values are same, again this will be 0. So in XOR, if there are opposite charges, the output will be 1, and if they are similar charges, the output will be 0. Okay, so let's solve this. This is opposite charges, so this will be 1. 0 and 0. 0 and 0 is same, so this will be 0. As 1 and 0, these are opposite, so it will be 0 and this will be 0. So 0, 1, 0, 1. What will be the binary? What will be the number, decimal number for this? So 0, 1, 0, 1. So add 4 and 1. It will be 5. Let's run this. We should get a 5. This is, here it is. Okay, so this is how you calculate XOR operator. Let's solve another question. So if I write 13, or let's take a big number. So 21 XOR 17 or 27, for example. So what will be the output for this? Binary of 21 will be 16 plus 4, 20 plus 1. So 1, 0, 1, 0, 1. Okay, 1 0 1 0 1. This is the binary of 21. Let's check again. Okay, correct. What will the binary of 27? So 16 plus 8. That will be 16 plus 8. Put a 1 here. Put a 1 here. This will be 24. Where we need 3. This will be 0. This will be 1. 24, 25, 26, and 27. So 11 0 11. 11 0 11 will be the binary of 27. Okay, let's calculate the XOR. Similar charges are 0. Opposite charges are 1. Again opposite charge 1. Again opposite charge 1. Similar charge 0. So solve this like we add values in mathematics. 1110. What will be the output of 1110? 1110. So add these three numbers, or put 1110 here. You can write like this as well. Put any number of zeros in front of them, doesn't matter, just like in mathematics. That's it, 1110. Add these three numbers, 12, 13, 14. 14 should be the output, correct? That's it. This is how XOR works. Let's move forward.